Hey, Tim Unkert here. In this video, we're going to create a Python program that will automate problems or automate the creation of problems, and specifically SAT square root type problems. And I'm going to bring up a Dog Island here and show you exactly what I'm talking about. Okay. So go here. Let's open up a little bit larger screen there. And so we're talking about some problem that is of the form ax plus b plus c equals some dx plus e. And you want to find the solutions for x that make this equation work. Now, a, b, c, d, and e are all different numbers. They're either, if they're in front of x, they're a coefficient. If they're by themselves, they're a constant, right? But we want to create a problem and have a solution, but have a bunch of these. Now, when I was teaching math, I used to come up with these each and every day because we were grilling these in preparation for the SAT. But it took some time, take maybe, let's say maybe 5-10 minutes to come up with a problem, because you got to make sure that the solution works and all that. Now, in this video, I'm going to create a Python program that writes to a text file that will give you basically infinite amount of problems and solutions. I'm going to restrict it a bit because otherwise it'll just take too long to run. But with my restrictions in place, I still came up with 500 problems. So that's more than the amount of days in a school year. If you have a 180-day school year, that's a few years of problems. So, and we can do that with an easy Python program. Okay, so, and I'm going to look at my notes over here. So I have this on GitHub. I'll leave the program, the link to the program in the description below. Okay, so first thing I'm going to do is just make a directory called Python programs to put this in. And I'm going to cd into Python programs. And in here, I'm going to create a text file. Let's call it square root problems.txt. Okay. And now I'm going to open up a text editor and create a problem. Let's call it what should we call it? We call it square root problems _yt.py. Okay. And let's set the background to dark here. No, set bg equal to dark. There we go. Okay. All right. So what I want to do is first create a class for this problem. So I'm going to create a class, and I'm going to call that class square root equation. And I'm going to instantiate that class, and I'll pass in the self. And then I'm going to have C1, that's like A, C2 is like B, C3 is like C, C4 is like D, and C5 is like E. Now, I could have just done it that way, but whatever. So self C1 is going to equal C1, and I'm going to change these. No. Haven't had much coffee this morning, so let's change those. And speaking of which, cheers. All right, cool. All right, so that's all we need for that. And then I'm going to create a method called equal sides, and we'll pass in self. And then let's see. So, and we're also going to have a solutions list, and that's going to be an empty list. Okay. All right. So now I'm going to do a for loop. So for x in range, let's break this down. I went a little higher. Let's go from 1 to 20, which is really 1 to 21 when you use Python. And let's say that a variable for the left side is equal to self.c1 times x plus self.c2. And we're going to raise that to the half power. So that's my square root. If you raise something to a half power, you're taking the square root of that. And then plus self.c3. Okay, the right side of the equation is going to equal self.c4 times x plus self.c5. Okay, and then we're going to say if the left side double equals the right side, well, then we're going to take the solution list and append x. And then at the end of this, we are going to return our solutions list. Okay, so we got that basically started. So now what we're going to do is we're going to basically open our text file for writing. Okay, and let me save this for right now, and let's just see. So we have square root problems.txt. We want to open that one for writing. Okay, so the way we do that is we can set a variable like file1, and we can say open square root problems.txt, and then we're going to append stuff to it. So that's what the A is for. Okay, so now this is going to get a little non-peppy 8 here. I might, I'm going to embed a lot of for loops here. So we want to run through each of the coefficients and constants. And I want to do it from, let's say, 2 to 10. So I'm going to use a range from 2 to 11 because you go one higher. So I'm going to say for C1 in range 2 to 11, and then embed for C2 in range 2 to 11. So it's going to go through, like, it'll start with 2, right? And then it'll run through all the C2 values, all the C3 values, all the C4 values. So it's going to come up with a lot of different potential solutions. So for C3 in range 2 to 11. Now, if I made this range a lot longer, it would, up to 100, it would take a long time for this program to run. And then for C5 in range 2 to 11. Okay, so we're embedding a lot of loops here. And I'm going to say the underscore equation is equal to a square root. So I'm creating an object here, square root equation. And I'm going to pass in C1, C2, C3, C4, and C5. Okay. And I'm going to say the equation solution is equal to the underscore equation dot, and then we're going to use the equal sides method. Okay. All right. And we'll say if the equation underscore solution does not equal none, so that's like null, but Python doesn't have null, it has none. We're going to say for solution, now this is another for loop, for solution in equation solution, and let me get this down, I'll try and explain it. If solution doesn't equal 1 and solution doesn't equal 0. So why am I doing that? I'm doing that to basically eliminate solutions with 1 and 0, because there's going to be a ton with 1 and 0. Like if you just, set it, I want like something higher for my solution than 1. What I'm going to do now is, I'm going to take file 1, which is that variable I set up here, and I'm going to write, and then what I'm going to write is just this is kind of like breaking up, and then a new line, and then I'm going to do file 1 dot write, and then I have to convert my solution to a string, so I'm going to do that, plus now I'm putting an A here. Why am I putting an A? I'll tell you in a moment, but it has to do with searching for, like, let's say you want a problem that has a solution of 2. All right, well, a lot of the coefficients in that problem, or some of the coefficients in the problem might be 2, or some of the coefficients that has a problem that has a solution of, say, 5 might be 2. So this just, if you search for 2A, that'll find the solutions, okay? So, and then I'm going to do file 1 dot write f string here, and c1 equals c1, c2 equals c2. Let's do c3 equals c3, c4 equals c4, and c5 equals c5. Okay, and let's save this, and then let's just check our formatting. Oh, see, so we're good with our formatting. We're keeping less than lines of 80 lines. That line would have gone over, but I included the slash to bring it down. A little formatting trick there. Okay, and then so with the first if, we'll just type else and then print there are no solutions or problems, something like that. I don't know. And then at the end, we'll go down here and we'll do file 1 dot close, just to close it out. Okay, and now what I'm going to do is do, let's open up the terminal and let's run it. Let's do Python 3 and then square underscore root underscore problems underscore yt.py, and it's going to run, and it ran. And we'll exit out, and let's do a vertical split here, and let's open square root problems.txt. And we'll see here, now my formatting, maybe I need to, I need to do a little bit more for my formatting. Okay, so right now you'll see the formatting isn't that good. So let's go to visual mode and go G to go to the end of the file, and then the $sign to go to the end of the line, delete all that, and then save it. And let's quit out of this vertical split here. And let me add one more thing, which is just file 1 dot write, and then a new line. What am I doing? New line. Okay, that'll space it out. Okay. All right, so now let's open up the terminal. Let's rerun it. And you see it runs pretty quick. And let's exit. Do a vertical split here and open square root problems.txt. And now you see it's formatted a little bit better. We've got kind of a spacing between C3. So actually what I want to do, let me show you why that's happening. So go to visual mode G, go to $sign to the end, delete it all. Okay, quit out of this. What's happening here? Let's go back into insert mode. It's getting pushed over. Okay, so I should have it like that. Okay, and honestly, let's go back here and just insert a comma. Okay, all right, so now we'll go back to the terminal, and sorry about that, and we'll run the program again, and there it ran. Exit, okay, vertical split, square root problems.txt. Here we go. Here's the formatting is a lot better. So we see this first problem, the solution is 3, and our coefficient in front of x, so we have 2x plus 3 under the square root plus 5 equals 2x plus 2. Okay, so let's use that and do our draw island here. So we've got 2x plus 3 under the square root. Okay, and then plus 5. And that equals now 2x plus 2 when x equals 3. Okay, so if this is when x equals 3. So let's check to make sure that I created this correctly. Okay, so if I do 2 times 3, I get 6 plus 3, so that's 9. Square root of 9 is 3. 3 plus 5 is 8. 2 times 3 is 6, plus 2 is 8. Okay, yay! Okay, so now what I did set with this A, so notice this has a 3 in it, and notice, it has a 5 in here, but let's see if we have solutions with 5 in them. So I'm going to do 5A and hit enter, and we'll see that we do have some solutions with 5A. So it's going to go, or when x is 5, okay? And so that would be these coefficients. So let's try that one out. So we've got 2x plus 6. All right, and then plus 8. And then that's going to equal 2x plus 2. Okay. Not all of these equal 2x plus 2, but I just happened to pick 2 that did. Okay. And this one's 2x plus 3. But all right, so x equals 5, right? So if we do 2 times 5 is 10, plus 6, 16, square root of 16 is 4, 4 plus 8 is 12. 2 times 5 is 10, 10 plus 2 is 12. All right, anyway, so you can come up with a lot of this. Now, notice I limited this quite a bit. So if I go GG to the bottom and go down to the bottom, notice there's almost 2,000 lines here. And, the way I spaced it, each one is about 4, but that's about not quite 500 problems right there with a very limited range in this particular, um, the way I set it up. So if I, for instance, went up to 100, I would have, a text file that was quite massive. But with this one text file, you can now, you basically have problems for the entire year. And so let's say it only took me 5 minutes to come up with each problem. Well, that's close to say 500 problems. So that's, you know, uh, 2,500 minutes, right? Did I do that right? Yeah, 2,500 minutes, divide 2,500, so 2,500 by 60. Well, that's 40 hours. So that's a full work week, and it took me about 20 minutes to come up with this problem. So I saved myself a full work week with Python. That's why Python's really, really cool. If you like this video, please like, subscribe, and hit the bell for notifications, as it really will help the channel grow. And if you've done so already, I thank you very much. And I hope to keep seeing you in the next video, so on and so forth. Thanks for watching.